Okay, consider the equation tangent of x equals x, and let's let x sub n denote the unique solution of this equation that lies in the interval 2n minus 1 times pi over 2 to 2n plus 1 times pi over 2. And then let's evaluate the limit as n goes to infinity of 2n plus 1 over 2 times pi minus x sub n, all multiplied by n. Okay, so let's do that. Okay, let's first note that, well, let me get my pencil going here, and then we'll note that x sub n is equal to tangent of x sub n. Tangent of x sub n. That implies that x sub n is equal to the inverse tangent of x sub n plus n pi. Okay, we're going to need x sub n prime in the process of doing this problem, so let's go ahead and find that right now. X sub n prime, taking the derivative of both sides of this equation right here, with respect to n, x sub n prime is equal to x sub n prime over 1 plus x sub n squared plus pi. And go ahead and solve for x sub n prime now, just using some basic algebra. And we'll get x sub n prime is equal to, let's see here, it's going to be pi divided by 1 minus 1 over 1 plus x sub n squared. Okay, now, obviously x sub n goes to infinity as n goes to infinity because you keep going further and further out to the right here. Okay, so if we take the limit of x sub n prime as n goes to infinity, this x sub n squared here goes to infinity, and so the 1 over 1 plus x sub n squared goes to 0, and we're left with pi over 1. So the x sub n prime converges to pi. Okay, so let's go ahead and evaluate the limit we want now. I'm going to use this arrow notation so I don't have to write limit as n goes to infinity every time I write something. Okay, so let's take this 2n plus 1 over 2 times pi, then minus x sub n, all multiplied by n, and that's what we want the limit of. Now, what's in the parentheses, these x sub n's get closer and closer and closer to the vertical asymptotes, which are at 2n plus 1 over 2 pi. So this difference in the parentheses is tending to 0, and n on the outside is going to infinity. Okay, so we have 0 times infinity here, the indeterminate form, 0 times infinity. So we're going to use L'Hopital's rule. But before we do that, let's replace the x sub n right here by the inverse tangent of x sub n plus n pi. So let's go ahead and do that. 2n plus 1 over 2 times pi minus x sub n times n is equal to 2n plus 1 over 2 times pi minus our inverse tangent minus n pi, and then all times n. That's a pi there, right there. All right, looks like a pi now. All right, let's make sure we've got this right. 2n plus 1 over 2 times pi minus our inverse tangent x sub n minus n pi, all multiplied by n. Okay, good. Okay, now, from this 2n plus 1 over 2 times pi, if we split this 2n plus 1 over 2 up, we get n plus 1/2, and then times pi. From that we get an n pi, which cancels with this negative n pi, and all that's left from this part here is pi over 2. So what's left in the parentheses here is pi over 2 minus our inverse tangent of x sub n. Okay, so we get pi over 2 minus our inverse tangent of x sub n. Now we're going to use L'Hopital's rule, so let's go ahead, instead of multiplying by n, let's divide by 1 over n. And we now see that we have the 0 over 0 indeterminate form. Okay, so we're going to go ahead and use L'Hopital's rule. And let me go back to this arrow notation. That arrow indicates a limit as n goes to infinity. Okay, so after one application of L'Hopital's rule, we're going to have, see, in the numerator we'll have negative x sub n prime, and I just noticed that I have x to the n right here instead of x sub n, so let me get rid of that. And we continue on with L'Hopital's rule. We get negative x sub n prime over 1 plus x sub n squared divided by negative 1 over n squared. Okay, but that's, this negatives cancel, and that's equal to n squared times x sub n prime over 1 plus x sub n squared. But x sub n prime tends to pi in the limit, so we have pi times n squared over 1 plus x sub n squared. Okay, so now we have infinity over infinity. This n squared goes to infinity. The 1 plus x sub n squared goes to infinity. So we can use L'Hopital's rule again. Okay, so after another application of L'Hopital's rule, we've got 2n pi in the numerator. In the denominator, we've got 2 times x sub n times x sub n prime. But as we take our limit, this x sub n prime goes to pi. That'll cancel with this pi. The 2's cancel. Okay, so we're down to n over x sub n. And that's infinity over infinity, so we can use L'Hopital's rule again, and that gives us 1 over x sub n prime, but x sub n prime goes to pi, so we get 1 over pi, and that is our limit. Thanks for watching.